Visualizing multi-view drawings. What is a multi-view drawing? A multi-view drawing is one that shows two or more two-dimensional views of a three-dimensional object. When we say two-dimensional, we mean that the object is drawn with two of the three dimensions: width, depth, and height. Multi-view drawings provide the shape description of an object. When combined with dimensions, which are used to describe the size and relationship between features in your drawing, multi-view drawings serve as the main form of communication between designer and manufacturer. All three-dimensional objects have height, width, and depth. Height is the measure of an object from top to bottom. Width is associated with an object's side-to-side dimensions, and depth is associated with front-to-back distance. A multi-view drawing is used so that the manufacturer can see all three dimensions without a three-dimensional object. These three views of a multi-view drawing are top, front, and side. Let us take this three-dimensional object and see how it would look as a multi-view drawing. First, let us look at the top view. Now, from the top view, we will take that same object and rotate it down to the front view. From here, we will rotate the three-dimensional object to the side, and you will see your right side view. Here is what your multi-view drawing will look like. The best way to understand orthographic projection is to imagine an object contained inside of a glass box. There are a total of 6 glass walls surrounding the object. These glass walls are where a two-dimensional object view will be created. We are only concerned with the three views: top, front, and side. These glass walls are known as projection planes. They are imaginary surfaces that exist between the viewer and the object. Now we need to use projection lines, which are imaginary lines that are used to project each corner outwards until they reach the glass wall or projection plane. Now we can connect these points on the projection plane with object lines. The orthographic projection process is then repeated on the other projection planes, or glass walls. Here is the orthographic projection of the right side. Here is the orthographic projection of the right side and front view. Now let us look at the orthographic projection of the top view. Here are the three views drawn two-dimensionally on the projection plane. Now that you can visualize three-dimensional objects and multi-view drawings, let us look at 4 three-dimensional objects. Each block has the same overall dimensions and color. What else do they have in common? Try sketching the multi-view drawings of these objects. The answer is they all have identical top views. Let us look at this a different way. We will draw a two-dimensional object onto a piece of paper. We will now extrude that drawing from the paper up to its three-dimensional shape. Here, the red indicates what is seen from the top view. Now let us go backwards. We will take the same object and lower it back onto the paper. This is what all 4 top views will look like. It is very difficult in today's world to name an occupation that does not require the ability to read and understand graphic information, such as drawings, charts, or diagrams. Knowing these skills will make it possible for you to interpret and understand drawings made in other countries, because drafting is a universal language.